All right, welcome back. Today we're going to be talking about double and triple bonds that may occur in our Lewis structures. The reason why we may see double and triple bonds is that if we don't have enough electrons so that everybody gets their own set of electrons, their own bonds. So what happens is when elements don't have enough electrons, but they're still willing to bond, what they'll do is they'll share more than the standard amount. So they'll share more electrons than normal. So they're all meeting the octet rule. So this can happen with a double bond or a triple bond. And we know that one bond equals 2 electrons. So if we have a double bond, that's going to be 4 electrons in that bond. And then if we have a triple bond, that means we're going to have 6 shared electrons. And this happens in our Lewis structures when we follow the steps as normal. And then when we do that, we realize that, oh, we're out of electrons, so that we can't continue. So what we're going to have to do is add in double bonds. So let's go ahead and do some examples and see how this pans out. So we'll start off with oxygen. So oxygen's O2. And we'll say, okay, draw a Lewis structure for oxygen. So step number 1, I'm going to count my total number of valence electrons. So for oxygen, we have 2 of them, and they have 6 valence electrons for a total of 12 electrons in our structure. Okay. The next step is to draw the central atom as the element we have the least number of. Now, in this situation, we only have 2 elements, so we know they're going to be bonded together with a single line. When I did that, I created one bond, and we know that one bond has 2 electrons, so that's going to subtract 2 from our total, so now we have 10. Okay. Step number 3, place a single bond from all other elements to the central element. Well, we can't do that since we already did. So we go right to number 4. Fill the electrons on the outer elements until they have the octet rule. So here, again, because there's only 2 elements, just start adding electrons in. So let's just pick the right side because I'm right-handed. What the heck? So we need to fill in 6 more because we already had 2. So now this oxygen meets the octet rule. So we use 6. We have 4 left. This oxygen, well, I guess it just gets the rest of these. So we have 4 left. All right, so we're done, right? We have no electrons left. But is this a good Lewis structure? So we need to check. So we already know that this right oxygen has 8 valence electrons. Well, how many does the one on the left have? It has 1, 2 in the bond, 3, 4, 5, 6. So this oxygen only has 6 valence electrons. So we have to say, is that acceptable? And the answer is absolutely not. All the elements must meet the octet rule in order to have a valid structure, because this would not exist in real life like this. So what are my options? What can I do? Can I just beg somebody else for 2 electrons? Probably not going to work. So what's going to happen is this oxygen is going to just end up sharing those electrons with this oxygen. So what's going to happen is we're going to look at these 2 right here. It could be any of these electrons. I'm just picking the top one because it's the closest. And it's going to move those 2 electrons into the middle, and we'll share those. So what this is doing is it's creating a double bond. So what we're going to do to show this is we're going to erase those 2 electrons, and we're going to redraw them as a bond. Okay. So what's happened is it's made 2 bonds in between these oxygens as our double bond, and it's allowed both of the oxygens to have an octet rule, to both have 8. So I'm going to rearrange those so it doesn't look as silly, because I know somebody's going to be watching and say, oh my gosh, I can't take that. So there we go. That's more what it looks like. So let's check these oxygens. Let's say, okay, do these meet the octet rule now? So let's look at the right one first. 1, 2, 3, 4, 5, 6, 7, 8. So yes, it does. It meets the octet rule. And I accidentally put a dot in there. Let's forget about that. All right, left side. 1, 2. Oh, geez. 1, 2, 3, 4, 5, 6, 7, 8. So both of these oxygens have 8 valence electrons. They both have 4 from lone electrons, and they have 4 from bonds. So what we saw here was a double bond. And a double bond occurred because we didn't have enough electrons to go around. We had to share them. So don't just start drawing in double bonds because you think it looks cool. You have to go throughout the steps of your Lewis structure. And then if you find out you have a shortage, then you can go back and you can create double bonds in order to share electrons so everybody meets the octet rule. And every element must meet the octet rule when we do these. Okay, we're going to do a couple more. Let's go over to carbon dioxide. Good old trusty CO2. So it's same thing. We're going to follow the same Lewis structure steps. So number one would be to count the number of valence electrons we have. So we have carbon, and we have oxygen. Carbon is 4. Oxygen is, we have 2 of those, and we have 6 total valence electrons. Gives us 12, plus our 4 from carbon, gets us 16. Now we're following the steps. Number 2, draw the central atom as the element we have the least number of. So when we look at our formula, we have 1 carbon, 2 oxygen, so that means carbon's going to go in the middle. And then we look at number 3, place a single bond from the outer elements to the central elements. So we have 2 oxygens. That'll be our outer elements. Okay, when we do that, how many electrons do we use? Well, we use 1, 2, 3, 4. So we lose 4. That leaves us with 12. Next, fill electrons on the outer elements until you obey the octet rule. So step 4, we're looking at the outer elements and we're going to fill in electrons until they meet the octet rule, reminding us that we can't go over the 12 that we have. So we're starting at oxygen. It has 2, so it needs to get to 8. It needs 6 more. 1, 2, 3, 4, 5, 6. Okay. Left oxygen. 1, 2, 3, 4, 5, 6. So we use 12 electrons, giving them 6 each. Okay, we're done. Since we're out of electrons, we can't do anything else. Now we need to say, okay, are we done with this Lewis structure? So we know that the oxygens meet the octet rule, but what about the carbon? How many electrons does carbon have? Carbon has 1, 2, 3, 4. So it has 4 valence electrons. It wants to have 8. So is this acceptable? No. We have to make sure every element meets the octet rule. But the problem is we are now out of electrons. We have none left. So what can we do? Our only option is to share. So what we're going to have to do is share from the oxygen. So what I'll do is I'll do the same thing I did last time. I'll just say, okay, let's just take any one of these 2. I'll take these 2 this time. What the heck? All right, I'll erase those and I'll put those in the middle. Okay, that's good. What else can I do? Well, I'll have to do it again. So why don't I go over here to this oxygen, grab 2 of them, put them in the middle as a double bond. So when we look at this, let's say, do these oxygens still meet the octet rule? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. They do. Does carbon have 8? 1, 2, 3, 4, 5, 6, 7, 8. So carbon does. So all of my elements now meet the octet rule. And we have a good structure. We have 2 double bonds from carbon out to each oxygen. Now, why didn't I put a triple bond on the right and a single bond on the left? Well, your OCD may tell you that's the wrong thing to do, and you'd be correct. Because it's when you have a situation where elements can be balanced and have the same bonds to each other, it's actually better. And we're going to look at formal charge coming up in the next video that would actually show us that that would be the better Lewis structure. Okay, so there is our carbon dioxide. We'll look at one more. C2H2. This will be your ethylene. Okay, so we'll follow our steps as usual, counting our valence electrons. So we have carbon and we have hydrogen. We have 2 carbon, 2 hydrogen. Carbon gives us 4 valence electrons, hydrogen gives us 1. So we have a total of 8 plus 2, which is 10 valence electrons. So we're going to say, okay, which element goes in the middle? This is step number 2. Draw the central atom as the element we have the least number of. Now, we have 2 of each, so how am I supposed to know what goes in the middle? So in this situation, I'll give you some trends. Hydrogen, we know, can only have 1 bond. So can hydrogen go in the middle? No. So hydrogen will never be in the middle. Carbon will most likely be in the middle all of the time. We'll see the opposite of that trend. So in this case, if we have 2 carbon, and carbon is supposed to be the central atom, what we're going to do is going to say, okay, we're going to have 2 central atoms this time. So most of the time, you're going to have 1 central atom for this example. If you have 2 as your lowest number, you're just going to put 2 of them side by side. When I do that, I take up 2 electrons with the bonds, and then I need to assign outer elements. So place a single bond from all of the outer elements to the central element, so I have 2 hydrogens. Now for this, does it make sense for me to put both hydrogens on one carbon? No. It makes sense for me to put 1 hydrogen on each side, right? So in this case, whatever looks most aesthetically pleasing is normally what happens, and this is due to bond angles and stress on the elements. So whatever allows them to space out the most actually turns out to be the best. So we used 2 bonds, subtracts out 4 electrons, so we have 4 left. So now we have to say we're trying to fill in the outer element electrons in step number 4. Well, hydrogen, they're already good, so we don't have to add any electrons there. So we just have 4 electrons left to distribute between the 2 central atoms. So normally what would I do? I'd put my lone pairs in the middle. So let's just say we'll do that. And now I'm out of electrons. Could you put the lone pair over here? Absolutely. But in this case, it doesn't matter because we don't have enough electrons anyway. So if we look at this carbon, it only has 4 electrons. It needs to have 8. This carbon has 8. So what we're going to do is say, okay, we're out. We have no electrons to spare. So what we're going to do is we're going to end up sharing again. So we're going to end up taking that lone pair, putting it in the middle, and this lone pair and putting it in the middle. And this is going to get us our triple bond. So we'll erase those. Now we're going to erase 4 electrons. I need to make sure we put those 4 back. So there's 1, 2, and there's 3, 4. So there's our first triple bond in the middle of the carbon. And this happens because we're out of electrons. We don't have any more left. So we have to share all of the ones that the one carbon had with the other. So in this situation, we now have the octet rule being obeyed by every element. The hydrogens are good. They have 1 bond. Carbon, they have 1. And then they're sharing 6 in the middle. So that's a total, or 6 electrons in the middle, 2 electrons on the outside. So it's total being 1 bond being 2 electrons each. So when we do this, you need to make sure we follow the normal steps for our Lewis structure. And then if we run out of electrons, we're going to be sharing so that all of our elements can meet the octet rule.